when s equals to 0.6, this distance from here, from here to here, it is 0.6. The spring is not stretched or compressed, like equilibrium position, and the block of mass 10 kilograms, which is subjected to a force of 100 newtons. So this force is external force which is applied on this block, has a speed of 5 meters per second down the plane. So the speed, initial speed which means the block is moving down the plane, is given. Find the distance when the block stops. So you have to find the distance. I would say this S2. Let's see if it comes over here. So what is the, I would say from here to here. So S2 minus 0.6 is the net displacement. So let's see, and when the block stops, so means V2 equals to 0, means it comes to rest. So as I mentioned here, that you will start your problem from this equation, work and energy principle. So let's write down this principle. First, T sub 1 means initial kinetic energy of the block equals plus all the work done of all the different forces. I'll show you the forces here on this block in a moment. So let me show you. So over here, so if I were you, I would start from the free body diagram. So this is the weight acting downward. This is the normal force acting perpendicular to the plane, and this is the third force which is shown here. And is it a rough surface? And there is one more force due to the spring will try to pull it backward. So this is F sub S. And these are the four forces according to this statement. Since it's a smooth plane, it means there is no friction present between the contact surface of the block and the plane. And you can see from here this diagram. So this is like a 90 degree, this is 60 degree, so this would be 30 degree angle, and this would be, so this component will be W sine 30. It is in the direction of the motion. So I want to show you that work done by the weight would be W sine 30 times delta S. Here delta S, I would say you can consider from S2, which is the final position, minus 0.6. For your convenience, I'm taking it rather than from this origin, I'm taking it from the equilibrium position, which is given in our question, that initially the block is 0.6 and the spring is neither stretched or nor compressed. This is the work done by the gravity. So let's see what is the work done by the applied force. F times delta S. You agree with your professor? They are both in the same direction. And the work done by the spring force is half, I would say, negative. Why negative? Because look, the force is backward and the distance covers or displacement is in the rightward direction or downward. That's why we have a negative sign here. Agreed? So these are all the equations which we need to complete this equation of principle, work and energy principle. So T1 would be what? Half mv1 square. Please open your calculators and help your professor finding the kinetic energy. Initial kinetic energy, half times 10 times 5. What do you guys get? Do you get 125? Now let's use these three equations, because we want to fill in all the summation. I'm focusing the right hand side is 0 because the block finally it stops. The right hand side is 0. Okay, so we want to find out the distance it covers, means S2, not even S2 minus 0.6 we can find it out, but let's find out S2 is actual answer. So let's do for U sub W 10 times G sine theta 30. So I'm going to plug it in the equation such that you will write down 125 plus 10 times 9.8 times sine 30. Let's say delta S for the convenience. I will solve it later on. Let's say delta S our variable, or it's okay. So plus F times F is 100 delta S minus half K. What is the K value? It is 200. It is given as 200. So I can write down 200 times delta S square equals to 0. So we have one equation, one unknown. So can you find for delta S? If you do the math, you should get delta S equals to 2.09. And I will leave it to you how to find. And delta S equals to S2 minus 0.6. So that means S2 equals to 2.69. This is the distance covered by this block. So we have found this successfully.